Good morning, everyone. I'm Sotadeology. In today's video, we're going to dissect Sotadeology Lecture 11, the gravitational mechanics of universe. In this video, we're going to dissect the gravitational mechanics of the universe. So we're going to get to know what quantum gravity is and then what classical gravity is. So this video, we're going to actually, explore all that you have known in physics and even, the part of physics that you are yet to know. So this, I believe you will be able to really appreciate Almighty God by the time we're through with this video, because you'll be able to see the signature of Almighty God in the mechanics of the universe, and then you'll be able to give glory to Almighty God. So now, with no further ado, let's quickly dive into it. But before we do so, I want to let you have an idea of what classical gravity is and what quantum gravity is. Now, classical gravity, when someone is said to be experiencing classical gravity, it simply means that the person is having a free fall from a particular height. So now, by having that free fall, the person will actually, experience weightless phenomenon. And by experiencing that, it simply means that there is a particular hidden relativistic, relationship of quantum gravity to that classical gravity. And so we're going to actually get that hidden relativistic relationship of quantum gravity to classical gravity in this particular video. So now, I call classical gravity, I call it constant deceleration. Constant deceleration. So you'll get to know what this is all about as we progress in this particular video. But I want you to really have the picture before we proceed by telling you that that phenomenon of having constant deceleration is synonymous to, running on a treadmill. A treadmill is a machine in a gym center. So the track's momentum of that machine is inversely related to the runner's posture. And as a result of that, the runner on that treadmill will just be running on one spot. So the momentum of that running will not translate to moving from one spot to another. So it will not translate to moving from one place to another. So that is kind of the check that we have in where I usually call it gravitationally controlled mass formation. So it's a kind of check that the mass worth should not be more than the constraint of the gravitational constancy. You understand? So basically, that gravitationally controlled mass formation is what the momentum of light is actually traveling, relative to. There is a big problem of, that particular situation where people are trying to get the luminiferous ether. So, they say luminiferous ether is what light is actually, waving in. And when the experiment was conducted by Mackenzie Morley, the Albert Mackenzie and Morley, when they conducted the experiment, they couldn't get any, traces of ether. And as a result of that, this, they said that light must just be traveling relative to anything. So they couldn't get what what light is actually traveling, or that what light is waving in. You understand? But basically, for light to be constant, whatever it is that light has to be waving in has to be inertia. And by having that, gravitationally controlled mass formation, it's a kind of inertial situation that light can actually, travel against. You understand? For us to have the ideal momentum. You understand? So now that is that. And then we have quantum gravity to be constant acceleration. So I'm going to use the time energy wave model, which is this diagram that I have right here, to illustrate for us to, really understand what it's all about. So now let's dive into it. So now there is something I want you to know before I get to this time energy wave model. This is the particular formula that is used to arrive at this instant trajectory of time. And then when you look at this time energy wave model, we have energy wave trajectory like this. And then we have time trajectory inversely related to it. Right inside it, you can see that we have equilateral triangle in the expanding phase of the universe. And then we have contracting equilateral triangle, which is the portion of the black hole. So now we call this gravitational phase and we call this expansion phase. So now this whole region, this top region, that is the classical realm, and this down region, that is the quantum realm. I want you to understand this chart very well so that you'll be able to understand the concept. Okay, so now here we have arbitrary suspension, which is the classical arbitrary suspension. And here we have arbitrary suspension, which is quantum arbitrary suspension. And that, you can see, maintains the symmetric nature of the universe by maintaining the trajectory of this equilateral triangle and then the flipped equilateral triangle right inside the black hole. Okay, that being said, now this formula of everything, I want to actually, go deep into the formula so that you understand what this formula is all about. We have dt dm, and that simply means that evolution of time per mass formation. So that this particular dt dm is what is going to give us this curvature. But basically, I use chain rule to derive this formula of everything. There is an intermediary variable, which is e, and in that chain rule, then I have to derive that energy by saying dt dE. So the instant trajectory of time that we have here is being elongated by energy. So we have that dt dE to be the intermediary solution of this particular formula of everything. And so the mass formation is dynamic, and so it has the feature, it has variable feature. So we're going to actually get the evolution of time relative to that variation feature of mass, for us to have the that continuous flow of time. So now, by having this curvature, then right inside the formula we have a nested linear solution, and that linear solution is what gives us this equilateral triangle right inside the time energy wave model. So now the capital U is the constant speed of the universe, and that is 2.5 times 10 raised to power 39. Now you can see that this value is closely related to the large number hypothesis of Dirac, but Dirac didn't get 2.5, he got 2.27 times 10 raised power 39. And so Dirac did not even get the annihilation of zeros to connect from classical realm down to the quantum realm, because there is divergence of classical mechanics to quantum mechanics, and the solution we derive now bridge the gap, and so we have this instant trajectory of time through the quantum realm to the complex level. So the value that we have outside here is the value of positron, which is, I will explain that later. So now the capital U is this constant. Now I want you to have idea of why is it that this constant is going to be the ideal constant for the universe. The reason being that when we explore, the conservation law of mechanical system, then we'll be able to get to know that this is going to be the ideal constant speed of the universe, in the sense that if we have a roller coaster and then we want a kind of momentum that will propel the mass what up to this topmost point, such that we can have momentum through the roller coaster to the other side. If we must achieve that, by considering the conservation law of mechanical system, then we're going to have 2.5 times the radius of the roller coaster above the ground level. And then when we now put the mass at the place which is being marked for that 2.5, 2.5 is the same thing as 2.5. So if we put our mass worth right at the marked spot, then we're going to have momentum that can travel around the roller coaster and then to the other side. So the solution is all about ideal distance that can actually bridge the divergence of classical mechanics to quantum mechanics. Then we cannot really have the ideal solution without having trajectory from the classical realm down to the quantum realm and even beyond to the complex level. That is it. And so you can see that here where we have arbitrary suspension to this positron, that is where we have the quantum entanglement at quantum level. You understand? And we can see that because the real number and the classical number will be commutative, and as a result of that, whenever we have the collision of the positron to electron, that will just generate a photon. So it means that we have a direct contact in that sense, and that will not be translated to mass work. So if that situation is what we have in the universe, then we will not be able to have all these visible particles that we have in the universe. So there is tiny difference, and that can only be instantiated by having a wide trajectory from the classical level down to the quantum and even beyond to the complex level. So I will talk more on that. So now we can say that this capital U is the ideal constant speed of the universe by making it to be 2.5 times 10 raised to power 39. And so now we have attachment of variable, which is m to that, and it is that m altogether, this U, capital U m, we have it to be strong conveying force. I call it strong conveying force because there is a kind of transportation from the strong nuclear force to the weak nuclear force, which is suspended at quantum level, at classical level, and then we have annihilation of suspended zero to get it down to the quantum level. So we have that kind of trajectory from the nucleus of Big Bang to the nucleus of black hole. So here we have the nucleus of the Big Bang, and here we have the nucleus of the black hole. So we can call it singularity, Big Bang singularity, black hole singularity. Now this horizontal line that we have, that is the line of infinite trajectory, and now this vertical line that we have is the line of instant trajectory. Now where we have the intersection of the two, that is the ideal location where the classical mass what should be for us to be conscious of happenings around the universe. So I will briefly explain about consciousness later in this video. So now we have this to be strong conveying force, and then we have this for m to be weak conveying force. So now the weak conveying force is suspended to strong conveying force. And so this is the line. So basically, I want you to know that here we have this trajectory to be at 45 degrees, and this trajectory is the trajectory of gravity. But basically, it is not falling from a particular height, you understand? But here we have momentum of mass formation to be inversely related to the gravitational momentum. And here, for you to understand this chart very well, we have the classical mass what at this point, which is 2,277,250,000 kilograms. That is by supplying this positrons value in our formula of everything. When you supply this value, we're going to get this counterpart. But solution, even though we have reality of the universe at the quantum level, the solution to that reality has to come from the classical level. And that is why we will have to supply this classical mass what inside our formula of everything again. And when we do that, we're going to have 5.7 times 10 raised to power 48 as the suspending trajectory from the strong conveying force to the weak conveying force. But basically, this is going to be, instead of having the suspension to be at 48th position, the suspension will be at 32nd position. So when we now annihilate the suspended zero, instead of getting 9.109 times 10 raised power minus 31 kilogram, we're going to get 9.109 times 10 raised to power minus 32 kilogram. And the reason that is so is because by using this classical mass, what we are traversing this trajectory second time, and then when time is at its default state, time is one-way traffic. So by traversing this trajectory second time, the trajectory we have to break this spontaneous, will break this suspension, and that will lead to radiation, and that will result to that decay worth of -1 kilogram that we have, at the power, -1 power decay of that value that we have. You understand? So now, with that, let me quickly tell you that time has two identities. When time is default, time is instant. Please take note of this. But when time is in relativistic scaling to energy, time is continuous. And so we can see that in this phase. Energy too has two identities. Energy by default, energy is infinite. When energy is in relativistic scaling to time, then energy will become discrete. But now, it is because it is because of the fact that the nature of energy is discrete at quantum level. That is why we have the tilt effect of time peregrination towards the past when there is momentum away from classical mass work. And then we have tilting effect of momentum towards the future when we have momentum towards the classical mass work. So with that, we can get to know that the discrete nature of energy in its momentum is shorter than the continuous flow of time. And the reason time is able to continuously flow is for the fact that excess mass accumulation is translated to expanding space. And as a result of that, we have elastic fabric at the classical level, such that when there is additional input beyond the constraint of the gravity's constancy, or beyond the constraint of gravitational constancy, such excess mass what will be translated to space, and so the space will be elastic. So if we now have input beyond, then the space can expand at classical level, but at quantum level it is not so. And that is why you can see that the real mass what at quantum level is outside the time energy wave model, and whatever trajectory that we connect to this positron will have extended into complex level system. You understand? So now the reason is, when you now have when you have excess mass formation beyond the constraint of light speed, such will cause discontinuous flow for the momentum to be retracted back to the constant limit of light speed. So that is what we have here. So you can see that the operations that we have, the mechanics that we have in this expanding phase, the operation at quantum level is different from the operation at classical level. At classical level, we have continuous flow of time. At quantum level, we have discrete nature of light speed. So that being said, fine. But right now, I want us to go deep into what classical gravity is. But before we do that, I want to briefly tell you, the difference that we have in Schrödinger equation. Schrödinger equation is Schrödinger equation is non-relativistic wave equation. Why we have a Klein-Gordon equation, which is relativistic wave equation. So I want to briefly talk about the difference between the two so that we can get to know what we're about to what we're about to deal with in this video. Now, in the Schrödinger wave equation, which is non-relativistic, we discover that at the point where energy is supposed to be zero, there is no activity at all. Schrödinger wave equation has no activity beyond the constraint of light speed. That is the zero limit of the equation. So from this suspension down to this energy curvature, that is where we have the nucleus of the black hole vertically like this. When that is flipped, we will have the singularity here, the singularity of the black hole. So now there is no activity. So in the Klein-Gordon equation, where we're supposed to have no energy, there is, in the Klein-Gordon equation, wave equation, we have non-zero energy state. And that simply means that there are activities right where we're supposed to have zero energy. And with that, when you look at it, if you now apply momentum to that phenomenon, for you to have the plane wave solution such that you now have the momentum to what is actually happening in the nucleus, then you'll be able to see that for the Klein-Gordon wave equation, we have momentum that is faster than the speed of light. But basically, the part of that momentum of the wave that is faster than the speed of light is said to be phase velocity, while the group velocity is still within the constraint of light speed. But for the Schrödinger wave equation, the momentum is actually not beyond the limit of light speed. You understand? But now, if we are now to interpret that, scientists settle for that by saying that, okay, since the group velocity is not beyond the speed of light, so it is still, everything is still being, constrained within the speed of light. But it is not so, because the moment you have that phase velocity is what is even needed in the transmission hologram, because the moment you have object wave intersection to the reference wave, such that there is such that there is uh, there is discrepancy in the phase, then you can have constructive interference for you to have more exposure. And by having more exposure in that transmission hologram, you can get the detailed information of the projected object. So now, with that, we now get to know that since we have the phase velocity that is faster than the speed of light, there is possibility for that to transit the momentum at the nucleus beyond that limit into the complex mechanics, or into the complex system. So that being said, now I want you to know that by having m right here, when we have a derivation that has the power of 2, it will be reduced to m, and in that kind of derivation you have limit towards the 0 right there. So the value of the variable that you have is to reduce the slice of time peregrination such that you can then have a point where there will be intersection to that curvature of the energy, for you to now have something that can actually fit the curvature. So basically you can see that what we have here as a solution that can intersect energy curvature here, such that we have standing wave, and by having standing wave, the projection is into the 3D, such that we now connect to the positron, because positron can only be instantiated in higher degree of freedom and power, which is the higher dimension to that substrate dimension. So we can call this whole area 2D while the projection is 3D. You understand? So now what we now need to know concerning the classical gravity that I want to review to you is that when somebody is falling from a particular height, we know that the person is experiencing light, is experiencing weightless phenomenon. And with that, we get to know that there is a hidden okay. So now when somebody is actually falling down from a particular height, we call it free fall. So the person will actually experience weightless phenomenon, and by having that, we get to know that there is a kind of arbitrary mass formation that is resisting that free fall. So how can we get to see that hidden mass formation? We'll get to see that hidden mass formation by saying, okay, let's say the person that is falling has a face cap on his head. So if the person should take off the face cap and then release it in the air as the person is falling down, we'll not get to see that the face cap will be suspended to that particular person that is falling down, and both of them will be falling down at the same speed of gravitational constancy, of gravitational constancy. So they are going to be falling at the same gravitational constant speed. So what that is telling us is that the cap will never, if the cap is actually released where my hand is and the person is right here, the person is falling down. Now the cap will never touch the person as both of them are going down, and so we can see the effect of that suspension. So the cap will only touch the person until when the person is landed on the ground, and that is when the cap will touch the person. So by having such suspension, we now get to know that there is a kind of arbitrary mass formation that is actually resisting that gravitational pull. You understand? And that is quantum gravity for you. Now, quantum gravity, I called it constant acceleration. So I want you to really have the picture of the inversely relationship. Inverse relationship of time, energy, mass tapestry that we have in the universe. Now, what the fallen person is experiencing is quantum gravity, because the only thing you can actually say it's happening right at that point in time is that the person is accelerating downwards. That's what you can say. But in the process of accelerating downwards, the person is actually the person is actually experiencing weightless phenomenon. And that is why we then believe there must be a kind of mass formation that is resisting, the free fall. So when we now have the relativistic flipping mechanism, such that we have another object that is relatively connected to the fallen person, then we'll be able to see that suspension. So there are two flipping mechanisms in the universe. We have dimensional flipping mechanism that will enable us to have, the structural picture of what is happening in the universe, and that will enable us to have shape formation. But relativistic flipping mechanism will allow us to see the hidden phenomenon of mass convergence, and that will be translated to smooth formation. So basically, now we know that quantum gravity is being experienced just as we are experiencing the classical gravity. So we have the effect, but I know some people might want to argue that if we have quantum gravity's effect relative to classical gravity's effect, then that could result to having no gravity, because there's supposed to be possibility of there's supposed to be cancellation of that gravitational effect, and as a result of that we might not have gravity in place. That is not so, because quantum gravity is so tiny relative to classical gravity. So we might not even have an elaborated effect of quantum gravity at classical level. Then another thing you need to know is that this symmetric nature of the universe is prominent or feasible at quantum level than at classical level. So we get to know that at classical level the symmetric nature is faded out, and that is why if you throw a stone in a space, even if you throw that stone with all your force, it will get to a point that the stone will stop. So if we have that symmetric nature, the stone is supposed to be going continuously without stopping. But in a universe where we have activities, where we have objects and things like that, that is not possible. That symmetric nature is only feasible where we have empty space. You understand? But basically, because of the virtue of compactness at quantum level, we usually have that nature of symmetric nature of the universe is so prominent at quantum level. And then you can see that we have different structure of the fabric of the universe. At classical level, the fabric is so elastic. At quantum level, the fabric is breakable. The fabric of the universe is breakable at quantum level, but at classical level, it is elastic. Okay, so right now, I want us to now dissect what I want us to dissect, the kind of phenomenon that will allow us to have this instant trajectory of time. And by having this instant trajectory of time, that means that we have global now. Now, in relativity of simultaneity, it is difficult to have a global now. And that is because of the tilting effect I said earlier on. But there is a point where energy becomes smooth. And when that is equal to the smooth flow of time, then we're going to have this instant trajectory. So right now, how can we now get that smooth nature of energy at this point? We'll get that by the virtue of this suspension. Now, we see that the moment we reach this suspension, then we have the nucleus to be so compacted, and so we have compacted gravitational field right inside this tiny space. That will now cause the speed of light to be accelerated. It will cause the speed of light to be accelerated, but it will be constantly accelerating because the equilateral triangle is being compacted, such as it's being so compacted to allow for that change in momentum. So we can translate that to a point where we now have curvature. So when you have momentum around a curved area, it will be angular momentum, and when you are in angular momentum, you'll be constantly changing speed level. So that will be translated to velocity. So there we can see the effect of that curvature by having an energized momentum right inside the nucleus. Now, the excess momentum will be converted to mass worth. It will be converted to mass worth because that constant speed must still be maintained. And as a result of that, we now have mass accumulation in the nucleus. So that mass accumulation, I call it arbitrary mass accumulation because we're trying to get the point where electron is able to, acquire mass. So in the nucleus, by applying this formula of everything, we know that electron in the nucleus is undefined. So by not being defined, that means it will have positive charge. And the virtue of mass accumulation is positive as well. So we're going to have the like charge or the like sign to do what? To repel each other. And so we have enormous repulsion right inside the nucleus to allow for space. And that is the resistance that we have against the free fall. Okay, so now by the virtue of that mass accumulation, the charge will be positive, and then by the virtue of electron not being defined, that will as well be positive. So basically we're going to have enormous repulsive force in the nucleus to create the necessary room. You understand? So that repulsive force is what we have as resistance to that free fall in that analogy of classical gravity against quantum gravity. So now if we have electron in this nucleus undefined, then electron will be defined in the Big Bang nucleus. This is the Big Bang nucleus, arbitrary suspension at classical level, arbitrary suspension at quantum level. So this region will be the Big Bang nucleus. So we have electron being defined there. So definitely the degeneracy pressure will be towards the edge boundary, while the degeneracy pressure will be towards the central point of this nucleus. So now with that we get to know what is actually happening. So what is actually happening in the universe is that in this nucleus we have a kind of momentum we have a kind of momentum that is attempting to be transformed to infinite momentum. But by the virtue of energy density, then we have the kick-in effect of gravitational expansion to electromagnetic contraction, and as a result of that we have a controlled momentum. So if we do not have this controlled expansion phase, then there will be no room for emergence of electron or particles that we can see. So here we have a suspension known as inflationary suspension. So basically, let me quickly use this to explain that. So here we have suspension. In the Big Bang nucleus, we have suspension known as inflationary suspension. And so you can see that gravitational field is being relativistically related to electromagnetic field. This red signal, that is the electromagnetic field. So this black signal momentum, that is gravitational field. Okay, so now by having an increasing gravitational field to a decreasing electromagnetic field, we have expansion of the universe. Now in the black hole, we have an increasing electromagnetic field to a decreasing gravitational field, and then we have contracting phase of the universe, which is the black hole here. Now here we have neutron star suspension, and so right here we have compacted gravitational field. Right here we have compacted electromagnetic field, and so that can be we can explain that to be strong nuclear force, and here we have weak nuclear force. So now what I want you to know is that the density we have here is different from what we have here. Here we have energy density, and here we have mass density. Now the tiny difference, that is the value, that is the virtue of the emergence of visible particles that we can see now in the universe. So now we now know that here, anytime we have momentum away against the gravitational momentum, we can see that the gravitational momentum is towards this central point where we have the intersection of infinity to instancy. So now anytime we have momentum away from this gravitational field, we have mass convergence, and mass convergence is meant to reduce the effect of that outrageous expansion, and also the mass decaying momentum that we have in electromagnetic field is as well to curb that outrageous expansion. You understand? So now when we look at this, we'll get to know that when you have, like, if we have a ramp like this, you have a tiny mass what on this ramp. If you compare the momentum of that tiny mass what to a massive object, you see that the massive object will quickly reach this point compared to that tiny mass what. So basically, when you have a downward slope the only way you can reduce, the momentum of object from here is to have that virtue of mass decaying mechanism. You understand? And the only way one can actually curb momentum in this uphill trajectory is by having mass accumulation, and that is why we have that. But what you need to know is that any excessive mass accumulation is being translated or being transformed to space, to the expansion of the space at classical level. Then any excessive mass accumulation at quantum level is being transformed to a controlled mass formation. So now we can say light is actually waving in gravitationally controlled mass formation. So that is that. Then another thing we need to know is that if we turn this whole diagram to be 2D, by the time we have time trajectory to connect to this positron, then we have connected to the 3D. And so that is the complex region, which is outside the time energy wave model. So now, since electron is not defined in the nucleus right here, then the electron electron is not defined simply because of the pressure that we have right here. So we can have positron in the higher dimension because there we have higher degree of freedom, and so there is going to be more room. There will be less pressure in that higher dimension, so we can have positron there. So the moment we connect to the electron of that higher dimension, that will be converted to positron because it will have to flip towards this nucleus. And so then by having this to be positron, then electron will become electron. Electron will be defined, and that is quantum entanglement for you. So whatever you get connected to outside the time energy wave model, its charge will determine what will be defined right inside the nucleus. So you can see that that quantum entanglement is actually beyond the time energy wave model of the substrate dimension, and that is why the transmission is faster than the speed of light. That is why the transmission is faster than the speed of light. And also, we have seen that in the Klein-Golden non-zero energy state. We have seen that right there. So now, I just must say that Dirac was an outstanding physicist because he discovered large number hypothesis, which is this particular value. Then he discovered the emergence of antimatter, even though he could not get, the link from classical mechanics to the quantum mechanics. So, in fact, I respect Dirac a lot. So, but by applying formula of everything, we're able to initiate the link from classical mechanics down to quantum mechanics, and that is that. So right now we now get to know the true nature of classical gravity and then the true nature of quantum gravity. So I'm so delighted to share this with you, and I just must say that when you look at this whole thing, you can get to know how powerful, how magnificent Almighty God is. So the signature of Almighty God that I said earlier on that we would see in this whole thing is that For instance, we human beings, we developed AI. God forbid if AI should get aggressive beyond control and then wipe out all human races. If AI could rewrite its own code such that they have some other generations, it will get to a point that no one will be able to convince them that they were created by human beings. But if you go down deep to the source code of the AI, you will be able to see the signature of human, source code right inside the source code of AI, because there is a point where humans develop the code too before the takeover of the AI's operation itself. So we'll be able to see the signature right there. Same thing is applicable to this mechanics of the universe. We know that the system that we have here is so powerful and so outstanding, and with that we can get to see the signature of Almighty God right inside the universe, like that. So this is the mechanical system of the universe. But if we were to look at the the chemical formation, the what should I call it, should I say biometabolism system of the universe, then you know that yes, there is indeed a signature of Almighty God in the universe. So that is that. I will put a link to my research publication in the description below. You can click on that to explore it further, and then I will put a link to my books on Amazon as well. Don't hesitate to subscribe to my channel so as to be notified for the subsequent uploads. I remain my humble self, Sotadeology. Thank you.